Hey programmers, Alvin here. Right now I want to go over a Python solution for this breadth first values problem. So we'll jump right in. This is really just a small variation off of our previous depth first code. And it's important that you understand both of these algorithms, and I would always be sure I know how to implement them really quickly offhand, right? And so we know, like we spoke about in our approach video, the breadth first traversal algorithm mainly relies on a queue data structure. So maybe to get the ball rolling on this one, I'll just use a Python list as a queue, and then I'll optimize it later on. So I'll just create queue variable, make an empty list. And really what I want to do is really begin that list with the root on it. And like we saw last time, we're probably going to have to protect against the edge case where our initial root is null, or like the none pointer here. And so we'll want to actually guard against that one explicitly. So here I'll just check, hey, if my root is none, then I'll just go ahead and return an empty list. And I actually don't need the parentheses over here. But beyond that, now I can have my main loop for the algorithm, right? So I want to loop while my queue has things on it. So I could just say while queue. And I start by removing the front element of my queue, right? So to do that in Python, what I can say is queue.pop, and you can actually state the index you want to actually remove. So if I want to pop the front, I'll say pop 0, right? And that will also return the element you just removed. I'll call that my current. And then from there, what I want to do is consider this node's children, right? So if they exist, I'm going to add them into my queue. And so what I'll check is, hey, if current has a left, then I'm going to append that left child into my queue. So I'll say queue.append, we'll say current.left. And it's also going to be symmetric for the right-hand side. So this is a really important thing about the breadth first and also the depth first solution. When you add your children in the iterative version, you need to check that they exist before you do so. Cool. And so now that I have those guards, we have the general shape we need for this algorithm. But now I want to actually construct my return value, right? So maybe up top, by the end of this function, they want us to return an array or a list of the values. When something leaves the queue, I'll go ahead and push that or append that into my values list, right? So I'll say values.append. I'm going to append the current.val. Nice. So that's looking pretty good. Let's go ahead and test this code. I need to be sure that after my while loop's done running, so once my queue becomes empty, like we said in the approach video, then you just return your values list. So let's give that a run. Put it through some test cases. Nice, and there we have our solution for this breadth first values problem. So we have a few things to actually speak about before we close the chapter on this one. So just in terms of implementation detail, I much prefer to implement this algorithm by processing my current value when something leaves the queue. An alternative would be to process a node or add it to your result when it actually enters the queue. So if you did something like this, like when you append your left, then you could append that left value to your values. Then you have to say over here, current.left.val. Likewise over here, current.right.val. But then you'd also have to explicitly initialize, your root val over here. So that's why I kind of don't write logic where I process my nodes when they enter the queue. It's much more easy to write it when something leaves the queue, because eventually everyone's going to leave the queue. However, this code I believe would pass in a similar way. It's kind of repetitive code, and I'm not really a fan. So I'll kind of restore it to its original and former glory. So I much like it like this. Nice. But something even more important is to talk about, the complexity of some built-in things we're using. All right. So in our approach video, we argued that a perfect implementation, an optimal implementation of a breadth first traversal should be O of n in time, right? And that's only going to be true if your queue operations of adding to the back and removing from the front if they both run in constant O of 1 time. And I will say that appending to the back of a Python list is O of 1. However, popping from the front of a Python list, a regular list, is actually going to run in O of n time. That's actually a common thing for many programming languages if you just use the built-in like array-like structure, because when you remove from the front of an array, let's say I remove index 0, that means that I have to shift all of my other indices to the left by one position, right? I have to take index 1 and make it index 0, take index 2 and make it index 1, and so on. And that's actually going to be very, very costly, right? So technically, I would say that this implementation as is, because of this line running in O of n time, the entire thing is n squared, right? And so if you're really in a pinch and you want like the maximal efficiency out of your breadth first traversal, then you should use a queue that actually has some optimality to it. Luckily for all my Pythonistas, that's actually built in, just kind of have to import it through a library. And it's a library that's included. So I think this is always fair game for most of your interviews. So what I can do is I can say from collections, so from that module, import something called deck, right? And so deck is really just a double-ended queue. And if you look up the documentation, it says that all of its operations that insert or remove from the front and also the back, they all run in O of 1 time. So I'll just show you how to refactor this code to use a deck. And it's actually really easy, right? So what you can do is when you create your queue for that list, you actually can pass that in as an argument to the deck function. And it'll return you back a special object that has these different methods on it, right? And what you can say is, instead of saying pop 0, the method you need to remove from the front of your queue would now be pop left, I believe. And you can also still use the append. So really just changing these two lines. And now I don't think any interviewer can argue that this is an n solution, right? This is a perfect implementation of breadth first with an O of n runtime, because this pop left now runs in O of 1 time. So I'll run this, should be passing, give it a go. Nice, and there we have our solution. All right, so before you hop into the next problem, I recommend that you have this solution down pat. This is probably like the only solution you can typically write for a breadth first traversal in Python. You're not going to be able to write any recursive version of this code. And that's because I know that inherent to like a breadth first traversal, I need a queue data structure. I need a queue order. If you try to write any recursive code by default, because all of recursion requires like the call stack, you would be kind of taking like a queue and putting it up against a stack, and you're going to have a really hard time getting the correct order, right? So for your breadth first traversal, writing it in an iterative way, just like this, is going to be your go-to solution. So practice this, and I'll catch you in the next one.